Alright, what's up, dudes? Happy Tuesday. Yeah, today's Tuesday. Um, Thanksgiving coming up real fast. Some of you guys may be off work. Lucky you. Not I. Um, I'm off for Thanksgiving Day, which is cool though. But anyway, so let's pick up where we left off. Yesterday, we actually spent too much time. I did a little bit of learning about what was it that I learned yesterday? It's if I don't even remember, then like, why did I do it? Um, I learned about okay, yeah, so I learned about like class method versus static method um, in class scopes that are separate from the standard local and global scope in Python, and I figured out like how to actually use them, and I went through these tests, and then I also learned about I was looking at okay, that's right, linked lists and versus arrays, and I got a better understanding of linked lists and what they do and their purpose and etc., and kind of went in depth on that, looked at caching, and you know, did a little dive into some of those topics. Asked Claude about how static method, I was, I remember where I quit anyway, I think was where I was asking Claude how the static method function right here knows what game M2 is, and I never really asked that, so I guess I will just ask that real quick. So let me comment out class method and re-enable static method, and then we'll copy this code and there we go. Alright, now so I'm gonna copy now that I have copied it, let me reset my extensions. Well, nope, I don't have to. They're all good to go today. So let's jump over to, I guess I'll just ask ChatGPT because I want to save Claude for like the hard questions. Because um, actually, no, I'll ask Claude because Claude is better. Um, Damn it, I didn't mean to do that. Well, since I'm here, I'll just go ahead and copy this stream, and I made a boo-boo. I copied and then copied again. Alright, so let's post this. Go back over here. Boosting our serotonin here. Alright, looks like that works, which is cool. And alright, so let's I don't want Claude to watch my stream, man. Alright, Claude, help me out here. Okay. How does the above um, codes M1 function understand or know what game object is? the reference to game inside of M1 isn't actually using any special knowledge about the class it's defined in. Instead, it's using the game class name as a global variable. Rather than X uses code, the game class is defined in the global namespace. When M1 references the game, it follows Python standard variable lookup rules. First looks in the local scope, then looks in the enclosing scope. Well, the enclosing scope actually, well, the enclosing scope it would find it, but it doesn't. Class scope isn't enclosing scope. Enclosing scope you might expect would include a class definition, but it doesn't. It's separate, and that was like the thing that I learned. Finally, it looks in global scope where it finds the game class. To demonstrate this, we can break it in. So we have class game static method, game into reference game from global scope. This works fine, print true. But if we reassign game now, oh well, that is interesting. That is cool. See, Claude is good. Look at this. So if we reassign game to none, then it doesn't find it. Now this will fail. GM1 raises attribute or non-type object has no. That's cool. Or we can be more explicit about how it's using the global name. Some other name .m2. That's one reason I said for class methods when they need to reference the class itself. This class methods receive the class explicitly. Or we can be more explicit about how it's using the global name. Well, yeah, duh. The class method version is more robust because it doesn't rely on the global name game, so referring to the class. Okay, it uses the class that was passed to it via CLS. Okay, so the class method is a little bit more like I guess you could say proper. It's more secure because it's not using a global variable. And this is an important distinction, so I'm really glad I asked this because this is important for me to understand. I didn't realize that. So a class object is considered a global variable. So a class object is considered a global variable at compilation time. Yes, class objects are global variables when... See, I didn't know this. Class objects are global variables when defined at module level. This is a key aspect of Python's namespace handling during compilation and execution. X equals 1 global variable class game. Game becomes a global variable. Y equals 2 class variable. Not global. Access is global X. Access is global game. Would fail. Y is global. Because it's not looking, it doesn't know what Y is because this isn't considered encapsulation because it's the class scope. It's using the built-in globals function, so we print game in globals true and type globals game. Class type. Compilation process handles this in an interesting way. Get bytecode class game at static method import dis .dis game.m1. So we create class, we create a static method m1 which calls game m2, but m2 doesn't actually exist at this point, and then import dis, we call it dis.dis, and then game, okay, get bytecode. This would show you that the reference to game is treated as a global variable lookup in the bytecode. This is different from how instance variables or class variables work. class variable, instance variable, method. Class var is looked up in class scope. Instance var is looked up in instance scope. Game is looked up in global scope. Print self is instance var, self class var game. The global, so that does work. But why doesn't the Y work then? It's because of being a static method? So if we just changed if we made it not be a static method, this would work. So let's copy this. I want to see this real quick. So let me write first though, what was the distinction between the class method and the static method that I just learned? It was okay, it was that static method finds the so I'll put static, the class method, and at static method example. Reminder of how to use a class method and static method to reference other class scopeable methods from another class. Using the CLS program or game object reference or at static. Okay, so we'll just put that uses the CLS arg can be filled with any namespace. CLS anything. Fish. So really I should just duplicate this. So this is considered an instance method. That can't be right though, because it doesn't get past um so yeah, my question is then is well, let me finish this because I was kind of all over, and I'm doing the learning thing again instead of the coding thing, but whatever. Life goes on, right? So it pointed out something to me that I wanted to address, and that was, well, for one, that it gets the game from the globals. That I learned, that was new. But also that let's see, where is it? Okay, right. So it doesn't know what y is because it's a static method, but down here in this instance we have a class variable, and then we just have a method without a decorator, and it prints out class var. Okay, I see, because it's is that's why you can get into trouble with forward references. So I still don't completely understand this though. How does it understand, like, how does passing the self let it know what the class variables are? Well, because the self is the instance, right? So the self is, let's copy this and say, I want to finish reading what it said, but and then I'll go to that. So this global name here is also why you can get into trouble with forward references. Class A, def method self. This fails if B isn't defined yet. So then we say def method of self, and then return B. This was because A is using B before it's defined. To fix forward reference issues, so that's called a forward reference. I didn't know what that was called. Forward reference. So a forward reference is when you refer to an object that has not yet been defined yet. You typically need to use string literals for the types or define them in the correct order. The global nature of classes. Okay, because but I thought, and see, that's another question. I thought it would let you refer to things that like don't actually exist yet. Damn it. See, and that's, I have a gap in my understanding there, because I know for a fact that that is the case. Well, like right here, I'm referencing M2, but M2 doesn't exist yet. You know, like at this point, M2 doesn't even exist. So it's just like, how does it know what M2 is? And I guess that's because it checks to see if the game has an M2, but at that point it doesn't have an M2. So like, is it, I gotta ask those questions to get the answer. I'm just assuming at this point. To fix forward references, you typically need to use string literals. So the global name server is also why you can get into trouble with forward references. So let's go back up here. This would show you that the reference to game is treated as a global variable lookup in the bytecode. This is different from how instance variables or class variables work. So you have class game with a class variable, and then you have the init, which takes self, and then an instance var. Self dot, then you have a method, which takes in self. Class var is in the class scope. Look at an instance scope, and then game scope. We're gonna print all those. And since there's global behavior is also why you get in trouble with references. And it defines class A, def method taking in self, and then it returns B, an instance of B, but B isn't defined yet. And I don't really understand why that is. To fix forward references, you use string literals or the types, or define them in the correct order. The global nature of classes is also why you can modify classes from outside. So you can say game.new method lambda self print added later. And then set adder of game another method lambda self print also added. Okay. Yeah, I understand that part. So as far as this class game, class variable, 100 class variable, def in itself, which one? What did I paste? Or what did I copy and paste in there? Okay, so is this one right here. And I want to know what allows it. First, what is the method that takes self called? Like, what type is that? Is it's called just a class method? Okay, so we'll say one is method here classified as a class method, and then two, what is self in this example? Where does it come from? Is it the class object or the class instance, which is not created until init is run, right? Alright, so let's get answers on that. So no, method here is not a class method, it's considered to be an instance method. Here are the key differences. So an instance method, it has no decorator whatsoever. Self is automatically the instance. Okay. And then we pass. Then we have class method. CLS is automatically the class. And then static method gets no automatic first argument. Self is the instance of the class. Here's the sequence. So we have def init self. Self here is the newly created instance. Self.instance var equals 200. Self here is the same instance. So when you do this, g equals game creates instance. So, okay, then calls game init, passing in the instance. So the instance is created prior to init, and that's a fundamental misunderstanding that I had. I previously thought that init created. I thought init instant. Well, that's just, I was just wrong there. Init is initialize. It's not instantiate. Otherwise, it would be inst, not init. It would be inst, not init. So that was just me being dumb. I like believed that early, and then it just stuck with me. So believing wrong things early is very dangerous. Python automatically passes the instance as self. Okay. So you can have self without init. I get it. I understand now. When you call g method, Python automatically transforms this to game.method passing in g. The instance g becomes self. You can see this more clearly if you do it manually. So we have class game def method, self is self, and then we say equals game g method, or game.method passing in g. Output will be the same for both. Self is main game object. Class object game exists after the class definition is executed. an instance doesn't exist until you call game. When you call game, Python creates a new instance, passes that instance as self to init, returns the initialized instance. To make this super clear, we have class game print. This runs when defining the class, and then this runs when creating an instance, and then class is defined now. G equals game. Now init runs. This runs when defining the class. Class is defined now. And then this runs when creating an instance. Gotcha. Okay, so you could just have this code, and instead of saying G equals game, you could just do game.method, and that would work, because when you call game for the first time, it's going to create the self, which is going to be passed. It's not going to be an instance. Well, it's going to be the class object. That's another question. What's the difference between that object and the actual initialized instance? Okay, so what is the difference between the game instance created at first call of game versus G, the G instance? They're actually the same thing. The single line does several things. Game creates a new instance of the game class. This instance is immediately passed as self to init. The same instance is then assigned to the variable G. There aren't two different instances. We can prove this. I think it might have misunderstood me, I'm not sure. Game definite self print in init. Self is ID of self. And then in method, self is ID self. So G equals game prints the ID in init, and then prints the same ID in method. G's ID is ID of G. To make it even clearer, class game definite self value and its setting value on instance. ID self instance equals game. Yeah, I think it misunderstood me. Um, let me show you. I'll show what I'm talking about with this code. Let's see. So we have class. Let's go over here and do we still have that code? Yeah, we still have it. Let's go over here and let's come right here, paste this, move this down. Okay. So we have class game, class var, um, and let's just do pass. Okay, so then we do, let's say, game dot method. Okay, and then we do g equals game, and then we'll do g dot method. So then we would do print ID of game well, that might not work actually because it's a, so this might actually not work. Let's see. Yeah, okay, so that doesn't actually work. You can't do that. Game method is missing one required position argument self. Gotcha. But if we called game dot method, then that would work. Okay, so you can see here we have okay, this is different objects. So when we run game open and close parentheses method, that creates an instance of game, and then so I guess it treats this as like, instead of saying g equals game, this is just game open parentheses close parentheses. And it assigns it to like that namespace, because whenever you run it again, you get the same value. 1942093849008. These two printouts are the same here. So, and the ID of G is separate. and then the ID of just game without parentheses at all is a different object altogether. Um, so you have three different objects here. You have game parentheses G, and then game no parentheses. Um, and these are going to be G and game, but parentheses are instances as to where game is just the actual class object. Um, so if we do, let's see, let's copy this and we'll put print type of game, and then print type of G, and then print type of game. And now let's see what we get here. So we get, yeah, the first two are instances of the game class, and the third one is the actual class object, so its type is type, because that's just what how it works in Python. The base type is type. You can't go like any further than that. I don't think. Okay, so yeah, let me ask it about this, explaining this difference. So when we call game for the first time, it creates an instance of the class. Just like when we assign G equals game. Let me show what those print statements would output and explain. So yeah, we have ID of game prints something like this, and then this number is this. Well, that's not right. Yeah, that's not right. It got that wrong, because it says that game and the first one and the third one are the same, but it's saying that's not true. It's saying that the first and the third are different, but according to the actual like running script with the code, that's not true. It's the same. It's the same object, which I thought it would be different too, because I thought it was going to create a new instance, but it's not. It's showing that the output is the same. So yeah, it says each game call creates a new instance. So game creates a new instance every time it's called. Game without parentheses is the class itself, a different object entirely. Gotcha. These create different instances. Gotcha. But they're all instances of the same class. Right, same as ID game. Game is the factory. Game makes a new product. You semicolon game. Yeah. Okay. But in my code execution in script, the output says the first game call and the second game call using ID to check their ID says the ID is the same. Yeah, so the ID it's giving me, the ID output is this. You're right about something interesting. The two game calls are returning the instance with the same ID. This suggests Python might be reusing memory locations that were freed up. First game creates an instance, prints its ID, and then that instance is immediately garbage collected since it's not stored anywhere. G creates an instance that we keep stored in variable. Second game creates another temporary instance. Python happened to reuse the same memory location as the first one since that memory was freed. We can prove this is about memory use by keeping references to the instances. And these will definitely be different because we're keeping both instances alive or by adding print statement. When objects are immediately discarded, Python might reuse those memory locations for new objects. The instances are still different objects, but they just happen to get assigned to the same memory location. Okay, I understand it. I understand enough here. I got it. I got it. I got it. Yeah, went a little far with that, but whenever I don't understand something like that, I feel like I can't move on until I really understand what's going on. Okay, so back to the broader principle, which was, let's see. So we have definite self, right? In itself is ID of self, self x 100. Which one was that? What was I not understanding? Okay, right, so I was confused about why it was able to access class var here. That was because it uses the self. As to where the static method doesn't know what the class variable is because it doesn't reference the self, so it looks locally and then it looks globally. It doesn't look in the class scope. Okay, I understand now. Got it. So yeah, now I have a solid understanding. I understand all this on a deeper level. It's some subtle differences here. So to that's like I'm done with the learning and asking Claude. Let's see. We have the proxtext assign function. So currently this would be an instance method. But it's not past the self. So if we go over here and I didn't really want to do this, but there's one more thing that I need to understand. So if we have class CLS, then we have def init, and then we have def method doesn't take self, right? And we just pass, or we'll just print true. Oh, hold on one second. God, I'm fucking tired. It's kind of aggravating me. It's like making me pissed off that I'm tired. It's impeding my ability to like do this, to understand this. I understood everything, and then now I'm like, wait, I'm kind of confused. If this, I'm still a little bit confused here. Okay, so we need to put pass here first of all, but before, like we do in our class currently, we have class game, and then we just have a function that doesn't take self. All right, and then so let's go over here. And let's run this to make sure it doesn't like throw an error, and it's not throwing an error. Which is good. And then we have so let's say cls.method and see if that works. Okay, that works. And then we say c equals cls.method, and that should work as well. Okay, now my question then is, if this is considered an instance method, how come it works without self? Like, and then let's say if we have x at the class level, okay, and let's print x. This is not gonna work. So the function call works, but when we try to print X, it doesn't work. Yeah, so it prints out true, but then it says, it runs CLS method and it says X is not defined when it gets to this line. Now if we pass in self and then did self.x, so this method is missing one required positional argument, self. Okay. I see. Okay. Okay. I understand now. Well, sort of. Okay, so all right. So this is a subtle thing here. My let's change this to CLS method. Right? Okay, now this works. Now, if we have, let's like do the other thing. So we have this thing, and then we have this other thing that I'm trying to do here, which is, not that. We'll say class CLS x equals 1. We have the method take self, print true. We're trying to print x, but it's not gonna it's not gonna work, okay? Because x is not defined. But if we comment that out, or we just remove that, and then we just print true, this works. So my question is, and I guess the way that I'm running this is, let's verify. So let's find this. Yeah, see, we're calling it from the game global like we're calling it without an instance. We're just calling it like, and that's my, so this would be, what is this called? Like, what is that type of function called? Like, what is this? This is an instance method. But this, what is this called? You know, like, what is this called? What exactly are we doing here? This is what I need to understand. So we're gonna have to ask the next best chibbity jibbity, or ChatGPT. This code will raise a type error. This is because a method is defined as is being called on a class without an instance. That's not true. That it does work. But it do work. Do it not? Oh, it do. It does not throw an error. That's not true. See, ChatGPT is not very good. Claude don't make that mistake, but ChatGPT does. It doesn't throw that error. It works. Yeah, that's you're absolutely. Oh, okay, I'm absolutely right. The code written does indeed work without throwing an error. Why CLS method works. In your code, method is defined as a function within the class, but it is not bound to an instance of the class because it lacks a self-reference. Python treats method as a plain function that happens to reside inside the class body. When you call CLS.method, you are directly calling this plain function, and no implicit self or CLS is passed. Methods without self or CLS are just functions. If a function inside a class doesn't explicitly have a self for instance method or CLS for class methods parameter, it's treated as a plain function, not a method bound to an instance or the class. Calling it works fine since a method doesn't expect any parameters. Calling it a CLS method works exactly like calling any other plain function. Okay. Alright. So what is the question I'm trying to ask here? Well, I think first of all, this is like bad practice, like not ideal practice. Like it kind of makes sense, but it's not like preferred. It's like a gray area. Like it doesn't. It's just not what people do. It works, but it's like a gray function. You know, like it's not ideal. And then like so then what should it be structured as? And I think the answer to that would be it should be structured as a I think it should be structured as a, well, either a static method or a class method, but I mean I would probably like lean towards class method, even though it doesn't really like matter. I guess honestly probably static method would be the most proper, I guess, because it doesn't really like modify or use the class object. Like it doesn't really use it, does it? And then there was a thing with the static method where static methods act like if I do static method, well, I can't just say all right, so yeah, that's the difference. If I do method and then I print cls.x, okay, so that actually does work. But I thought it wouldn't work unless it was a static method. Which thing didn't work? Oh, I know. It was the M2. It was if we had def method 2 and that just did whatever. If we were to call method, let's see, cls.method2, okay, so now that works. But if we just did method2, that doesn't work. Now if we do at static method, no, it still doesn't work. Man, I'm just like, dude, there was something, I'm almost positive. There was an instance wherein if I used static method, it worked, but if I didn't use static method, it wouldn't work. What was that? Did I have that? Let's see, regular function within a class. So then we just say game.x. Class game x1 static method. Okay, option 1 doesn't work because class scope is not equal to global scope. Class scope not checked automatically. Okay, so no, that was the one that worked. That was what I was thinking of. It didn't have to do with static method. It had to do with it had to do with the me referring to the class variable using the class variable namespace. Yeah. Okay. So I was just confused there. We have oh. All right, so I'm gonna take a break. I'll come back. We'll see. I gotta wake back up because I'm just like fucking exhausted right now, bro. I'm the caffeine is just whatever. I guess it's not doing the trick. So I say I mostly understand this, which I do, but I'm still a little bit mixed up with how exactly is this code. We don't even need the init. I'm trying to minimize this as much as possible. Let's get rid of this. Because I want to understand this before I stop. I need to understand the difference between this. So if class CLS x equals 1 def method print CLS x, and then we call CLS method. Okay, and this works because it's treating it just as a regular function. And it's accessing the CLS global to get X. It's not accessing it like in a what's it called? Embedded, not embedded. It's anyway, within the function, like it looks encapsulated or whatever. It's not finding it in that way, like function within a function nested type deal. It doesn't work like that. It's not looking outside of this function to find X. It's looking at the global variable CLS and then accessing X in that way. So yeah, the question I have is like can I call an object, or how can I call a function on CLS? How can I call a function in this way? Is this considered a method? Is CLS considered a class object or a global variable? That's where I'm just confused. I wanted to understand how this works on a deeper level, because that's how it's currently implemented, but that's not like really optimal. So it says method considered. No, not method. Well, yeah, it's method considered a method. Yeah. No, method in this case is not a method in the usual sense of Python's object or in a program. Instead, a method in Python is a function that is bound to either an instance or a class. Since method does not have a self for instance method or CLS for class methods, it is not bound to either an instance or the class. It behaves as a plain function that happens to be defined inside the class body. Thus, method is just a function in the class's namespace. You can call it like a regular function using CLS method. What is CLS in print? CLSX. CLS. No. That's not what I want. This works because method is just a plain function within the class namespace. When you call Python treats method as a regular function. No, I meant what is CLS in the context of CLS.method? So then it said, how can I design? So it said it would convert it to a class method, right? If you don't need access to the class itself, you'd make it a static method. And then is CLS a class object or a global variable? Okay, and then finally is what is the difference between a static function and just a plain function as it existed at first? So is CLS a class object or a global variable? In this context, CLS is a class object, not a global variable. Python automatically defines a class object inside its own scope during the class definition. However, if there was it would shadow the class name only if explicitly accessed in the global scope. Oh, so this is interesting. You can have a global var named CLS, but then create a class called CLS, and if you call CLS method, it knows to refer to the class, but if you do print CLS, it will print out the global variable. Now that's interesting. Inside the class body, CLS refers to the class object itself. Outside the class, it depends on the variable scope. It will shadow the class name when accessing the global scope. So in the context of CLS method, CLS is the class object. What is CLS in CLS.method? In CLS.method, CLS is the class object of the class named CLS. Class objects are first class objects themselves, meaning they can be passed around, assigned to variables, and have attributes or callable methods. When you define class CLS, Python creates a class object with the name CLS and binds it to the variable CLS in the current namespace. So CLS is the class object, and when you call CLS method, you are directly invoking the function method that is inside the class object. In this case, method is a plain function that is defined in the class of namespace. It's not a bound method since it lacks self or CS. Gotcha. So it's not a method because it's not bound using self or CLS. Got it. Method not passing any implicit arguments such as self, for instance, methods. Okay, so now I'm remembering. You can, so this versus using the static method decorator just allows basically like it's like a comment. It functions like a comment. It lets them know, hey, this is just a regular function. Like it's not. It doesn't rely or modify on anything in this class. It's just like kind of should go here logically speaking. But you don't need it. Why does CLS have access to itself inside the class body when you define it? Just refer to the class object directly. Class object versus global variable. Well, and then if you assign it as a static method, that would help it show up in like if you looked for all the methods that existed or whatever. Class object versus global variable. There's no global variable. A runtime object that Python creates when the class statement is executed. CLS method, CLS class object, not an instance or global variable. You're calling a plain function as part of the class namespace. Okay, what is the difference between status function and just a plain function? Static method, or static method rather, declared with static method and a plain function as it existed at first. This is a plain function living in the namespace of the class. It is not bound to an instance. Python treats it as a simple standalone function. You can call it as CLS method because it is accessible as an attribute of the class object. A plain function within a class is rarely used directly. A plain function within a class is rarely used directly unless there is a very specific reason to be confusing in terms of design and purpose. And the static method, it's the same exact thing, you just have the decorator, right? Yeah, same exact code. It does not receive an implicit or class. It behaves like a regular function but is logically grouped with the class for organizational purposes. Right. Actually, you can still call it using CLS method or even be an instance like CLS method. Use case. So would you be able to call this one with CLS method? I think you would. I just want to like see, basically they're the same thing. Okay, here we go. This is the difference. So if you have CLS instance method, you try to call it on the instance, it doesn't work unless it's a static method. Right? Am I right here? Yeah, am I wrong? I'm wrong here. Let's see. Let's see. Bam. That's what I was talking about. Okay. So it was a little mix. I was mixed up. Fucking tired, okay? Tired. Alright. So I had static method. So using static method, you don't have to pass the self. Use static methods, you can still call it use case static method when you want a function to belong to a class logic if it doesn't need an access to an instance specific self or class specific CLS data. So define without static method, treat as a regular function. No connection to the class or instance, part of the class, but it doesn't require self or CLS. Rare and confusing design choice. Use pre-utility functions related to the class. May look like an accidental omission of self or CLS. Clear intention of usage as a standalone function. Gotcha. Clarity, intentional design, tooling, initiative. So it says, a static method explicitly signals to readers of your code that the function is tied to the class for organizational purposes, even though it doesn't need instance or class context. Intentional design. Without static method, a plain function in a class could be mistaken as improperly designed or missing. Using the decorator removes ambiguity. Tooling and introspection. Tools like blenders and IDs understand static method and can provide better support, identifying usage pattern or checking for correctness. It makes your code more Pythonic and adheres to conventions. When would you use a plain function instead? Temporary hack during development. You may leave out decorators to get something working quickly. Legacy code. Educational difference in clarity. Final verdict. While plain function works in practice, using static method strongly preferred. Also, can't you not call a plain function from the instance, but you can call the same exact function using static method? A plain function inside a class cannot be called from an instance, but when you declare it as a static method using static method, you can call it from both the class and an instance. When a plain function is defined inside a class, it is not bound to either the instance or the class. It is simply a function that belongs to the class's namespace and can only be accessed directly from the class object. So you say my class plain function. Say object my class object plain code raises type error. Try to call Python tries to bind the instance object as the first argument itself to the function. However, since plain function doesn't accept any arguments, this results in a type error. Right, okay, understood. Static method. When you decorate the same function, Python treats it as a static method which does not expect self or CLS to be passed automatically. This allows it to be called from both the class and an instance without any issues. Why does it work for the instance? Python does not pass the instance, self, or the class as an implicit first argument. The method behaves like a regular function, ignores the context of how it was called, whether via the class or the instance. As a result, you can call it both ways. Can we call from class? Yes, yes. Okay, cool. Alright, flexibility static method sure the functions to be called. Blah, 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 blah. Readability, plain design, consistent with, yeah. Okay, easy. Understood, fully understood, 100% understood, 1000% understood. There's layers of you understand it, and you think you understand it, and then until you don't, and then you delve deeper, and then you understand it until you don't, and then at a certain point you completely understand the concept, like you understand the whole thing. And I think now I understand the whole thing. So we'll just put reminder that, well, it needs a title. We'll call it the we'll call it plain function in class bad practice. Yeah, just that. So a reminder that defining a function inside of a class without the static method decorator to denote it is a plain function placed in the class namespace organization purposes is bad practice. should use decorator. Also, if no decorator, can't call this function from instance, throws error, type error, type error. Yeah, the coffee or whatever is finally starting to hit me. I'm waking up a little bit more. All right, so cool. I understand. And we need to let's see. Need to convert this to, I guess we can, I mean, it doesn't really matter. Like, I don't think it really matters as performance wise. I guess technically it would be more properly classified as a class method because we're referencing the class. Like, we're referencing the class's enter continue text function to either static method or add class method. Probably better classified as class method since it refers to class object. Yeah, so that's literally all we would need to do, I think, for this, and then we would do the same for all the other things. So static method, adding static to all static methods in classes, and we'll duplicate this, and well, actually, you know what? I'll just say static method slash class method, and just put add in a static method decorator slash class method. Static class methods in all classes. Currently, we just write these as a regular function without the decorator, which is bad practice. And yeah, so there we go. Alright, so now when we come back, I can actually like finish. You know, when you learn, it doesn't feel like progress, but I needed to understand that. That was something I needed to understand. It's just, you know, it needed to be done. Learned about linked lists, etc. via Claude. Yesterday, did I not continued? Did I not learn about? I thought this was yesterday. Yeah, so I could have sworn like I did a full hour yesterday. I'm quite certain. Learned more deeply about class methods, static methods, decorators, and associated logic concerning class function, class plane functions, and syntactical rules. Yeah, and then today we did what time did we start? We started at well, an hour and 32 minutes ago, which would have been 10:25. 10:25. 24. Let's see, 10:24. 10, and then 33 would be 24. Yep. So 1024 to 1158, which was a really fucking long time, man. Like, this is too long. I need to finish this and not be dilly-dallying with just learning. No time to learn, buddy. You just have to finish. So we did this again. We really just continue doing that more to 1158. Continued learning. What do you believe about ran some tests to verify behaviors, etc. Yeah. Finalized decision for final fix to prog text assign function issue. Refactor issue. But did not implement. But did not implement or test. So yeah, that's it for now. We're gonna take a break. I'm going to I might go donate plasma. I might yeah, I might donate plasma. I might go to the gym. I'm like so tired right now, but I need to wake back up. So I'll see y'all later. Ooh, I forgot to re-enable my cam. It's a big deal. Alright, yeah, so I'm out of here and I'll see you guys